Hello, good evening. Welcome to Coding Nights ANZs. And tonight is a special day. We have special guest, André Baltieri. How are you?
Hi Marcel, finding you.
Yeah, well, it's a pleasure having you here. I know you've been on the technical working with the technical community for years, for decades, right? Like you've been your Microsoft MVP for more than 13 years, and I've been
Yeah.
following your work for a long time, even I would say long time. And, it's a exciting topic you bring like tonight. And just looking here, like creating agents and workflows with Microsoft Agent Framework. Well, could you give just a teaser of what we're approaching here?
Yeah, that's cool. So my intention today is to show you not just the code because I think coding agents nowadays is a very easy task. It's not difficult. Maybe manage some storage or some other things are a little bit challenging, but the agent itself is pretty easy. But the agent thinking, I think, is the most tricky here because we need to think a little bit different from when we coding agents and we creating APIs or something like that. So I want to also to bring the thing to the table
Yeah,
today or tonight because here is
yeah,
night.
we're different time zones,
Yeah, we're
right?
different
So
time zones.
in Australia, New Zealand is just it's evening. In Brazil, it's early
Yeah,
morning.
yeah, but I will bring you a real problem. We implemented agents here. It's still not running fine. I will go into the details during the session, but I hope you will figure out when to use agents, when to write down your code because they will coexist.
Yeah. All right. So before we start, Andrea, let me just walk through the well the audience in here about the user group. So we are Coordinate user group. We're a community group of developers. We love code and follow best practices on software development languages and technologies. In general, we focus a little bit more on the Microsoft stack, but are open to any technologies. And one of the things you're gonna find in here, like the purpose of the user group is that, well, our intent is to enable developers with practical knowledge to excel and launch their careers. So, well, if you're like a junior dev, a technical leads, like you're in between, we're all learning in this journey. And you're always going to find good content in here that we come and share in the user group. I also like to mention that we're part of AzureTire.com. We're a group of enthusiasts where we get to share the latest and greatest the cloud native space. We're sponsored by .NETFoundation.org, which is the entity that looks after the different open source .NET projects, and JetBrains software tooling for developers. With no further ado, Andre, I'm just gonna bring your slides, and the floor is yours.
Okay, let me start a battle here with my Mac.
No, all good.
Just
Yeah.
a second, because I'm using two monitors here,
Yeah.
but I'm gonna present my second screen to you
Yep.
because on my first screen, please let me know if you can see my
Yep.
screen. Okay,
Slides coming.
it's just 1,000 slides. I promise you one thing. Just kidding. I would like to start by just putting in the same line some important concepts before we go to agents. So if I'm going to basic, please let me know on the chat on the messages, right? And if I'm going too fast, you can also ask any questions here. Okay, this is part of some material that I have to regarding math. Okay, was translated from Portuguese to English. During the code, I think that will be some short words in Portuguese because I took it off from production. But I will translate on the fly to you. Okay. I will be very short here. Okay. First concept we need to understand and to differ from agents, LLMs, right? LLM is a large language model. It's basically a big function, a neural network trained over machine learning, deep learning, which to simplify all the things, we input some text and it can predict the next token to us. Just it. LLM itself is just it. Okay. It have some limitations. It's frozen in time, right? It was trained with some data in a point of time, and it do not have updated data. And I deep hope that it do not have your private data. If it have your private data, something was exposed, not good. They all know they are specific, right? So that's why we have so many different models to work with code, to work with math, to work with general purpose, uh, and in special they hallucinate. Okay, so they don't know how to say I don't know. They will always generate some results for you. Okay. And also LLMs, they can't take actions. They can't take any actions. The vanilla LLM itself cannot take any actions. It's just predict the next image, predict the next audio piece, predict the next token, right? Just it. Here's why RAG MCP piece tie together with LLM. And so, at least here in Brazil, I see a lot of confusion regarding agents, RAGs, MCPs, skills, and this sort of thing. So, agents will replace MCPs. Agents will replace RAG. No, they can work perfectly together because RAG solves the knowledge problem. So we can use RAG to feed LLM with data LLM was not trained for, did not have. So you can load your private data using RAG. And MCP gives the LLM some power, some additional power to do something. For example, MCPs work like tools. You give LLM a set of tools, for example, to create something in your database and to do something inside your environment. So again, I will not take so many time here. They work together. This is not one piece do not exclude other, right? The most important to us here is the agents, right? Agents use the LLM. It is connected to an LLM, but it can operate in loop. It can receive information. It can receive what we call goals to do, and it can interact in a loop. We call it a react loop, reason plus act, and it can do an autonomous job. We can say that an agent is a sort of program which is autonomous. He knows where it is. He knows what to do. So he can break down complex tasks in fewer steps. He can plan. He can decide what to do. He can interact in this loop until this is done. So here is the big catch of everything, because agents is a different thing of what we have today on development. It is a different way of thinking. When we start to write an application, we need to think about everything that is possible inside our application, and we need to map all this points so the user can do this, can do that. When we go to agents, as they are autonomous, they know have so much knowledge in their heads, they can take unpredictable ways. And one thing, do not exclude other. I will show you this in practice to you today. So we merged some C# code with some agent code because they coexist. So uh, they work in different ways to different purpose, and you can plan, have your agents and your C# code working together. I think this is the best word possible, right? Okay. Uh, then we have another term, which is skills. I think you probably heard of that because we are flooded with information about skills on the last months.
Mhm.
So skills are small capabilities that we can share among our agents. So this is cool because I can pick some abilities that I have. For example, I will bring this to my scenario. I create content every day, and as Marcel said before, I start my first article was written in 2004. I think I wrote
Mhm.
my first article, and since then I have been publishing on blog, publishing on other platforms. So I have I did a bunch of everything I can remember I did. Sent it to an LLM and asked him to create a skill for me to write like me, to act like me, because the most difficult part of my job today is when I create a content. I have a marketing team with we are 6 people here in my company today, so it's not me alone. I just sit here, record, and send the videos to the guys. They cut the videos, they spread the information, they use my social network to share information. And uh, for social network, for emails, for example, I have to review all this information. So I had to written this information before by hand, and then I send to guys from marketing, for example, and they have a different view, a different approach from my technical approach, because I'm a very technical person. So my articles is very good for you guys, for example, because you will find it very useful. But when it goes to the social network, we have so many different people that will probably do not understand what I'm saying. So that they have this this role called copywriting, right? That they rewrite the article, the piece of the article. We call it call to action. It's a small text calling the users to read the article itself, and they have this job to rewrite this and with other words that will call attention from the guys. This kind of thing that you see, oh my god, MCP is dead. This kind of marketing,
Mhm.
and we reduce this to a skill. So for example, today I have a writing review skill, which review my articles and say, hey, this paragraph is too long. For example, you should uh, uh, do it small. Uh, in this topic is out of the context of your current article, so you better to write and separate the article to that and link them together. And we have a copywriting agent also, which a copywriting skill, which act as a copywriter, grab this text and generate a smaller text to us with the call to actions. And as this is another area, this not sure if you know Neil Patel and other big names from marketing. They wrote books about
Mhm.
how to write a good text for everybody. And so we transformed it in a skill. And the good thing about skills is that they are small capabilities Okay, I know how to write a good article. I know how to extract hashtags from an article. They are passive, so you can use a skill for your project or globally for your AI. So they are passive. So every time I say I want to review an article in my prompt, they will try to trigger this skill, and they can be reusable. They are reusable. They can be used in different agents, so we can share these skills. Right? Very cool. Uh, sorry. So full picture LLM is the brain. RAG is the memory where we store the data and everything else. MCP is the nervous system, the tools that provide us, and skills are the learned behavior. Okay, agents will do the things, will run everything to us. Okay, let's move to a real problem. I think you're gonna understand it better. Just two points here. When we deal with LLMs, for example, AI itself is stochastic, which means they will produce a different result unless you cache it. It will produce a different result every time. Okay, so the result I will produce here is different every time. I will run this agent via C# and Rider. And by the way, sponsored by JetBrains, so I'm in the right place.
Yeah,
All
yes,
right,
that's true.
and um, it will produce every time will produce a different result. Okay, this is the main point here, because sometimes you want to produce an idempotent code, which is the same input produces the same results every time, right? Okay. Today we are one of the biggest communities here in Brazil. We have more than 8,000 students, and we run something periodically called a challenge here, which we compile some real world problems and open it to our students and say, hey, solve this. The last one we did about design patterns, and we created 23 different challenges and put this to the students, and hey, solve each challenge with one design pattern from the Gang of Four book. So we had over two, uh, 2,000 a thousand submissions, and you know, 1,000 submissions with 23 repositories, it's almost insane. It's impossible to review all this by hand. So we decided to create a review agent, a writing agent, a schedule agent, and a marketing agent to do all this job to us. Uh, Sadly, we did not had time or lucky to implement this. The At least the most cool part, because GitHub has some limitations. So we use the GitHub API, and so we have a limit for the request. So it was not run on the fly. We had to run it at background. Okay. Good. So I will bring the review agent part from here, because there are other things to. This is the easy part to show you the difference. The other ones are very basic. They are not so cool as this one. Uh, Regarding math, okay. If I'm going too fast, is because I have a lot of things to do. You can ask on the chat, okay, or Marcel, if you have any
No, all
thought.
good. You're on good pace. Yeah, that's all
Okay,
good.
all right. Uh, Now comes the good part, the Microsoft Agent Framework. So how can we build agents using .NET and C#? Because it's our our loved language, C Sharp and .NET. And Microsoft has doing such a great job over this AI integration. Everything started with Microsoft Extensions AI. Microsoft Extensions AI is uh, a, a, I pretty much can call it a Surface library, which we can. It's an abstraction for OpenAI, Claude, Copilot, and other things. So we can, instead of connecting direct to OpenAI and have to follow the OpenAI rules, the OpenAI API contract, we can just connect with Microsoft Extensions AI, and we have a bunch of features from our side. This is an abstraction layer to us, which is very good because you have almost the same code for whatever the AI you're using. This is the first step. So the Microsoft Extensions AI. Then last year I did. I put a lot of effort around Cement Kernel. Microsoft had two main libraries, Cement Kernel and AutoGen, which was two main libraries. Cement Kernel was to handle all this stuff related to LLMs, to chat completions, to working with the LLM itself. And AutoGen was more related to agents, workflows, and some more a LangChain like sort of that. So they decided to unite all this in a new framework, which I think is a better idea because we now have just one tool, one framework to do it all. So we have now the Microsoft Agent framework. We can do agents, we can do chat completions, we can do everything inside this. I just don't agree with the name. Microsoft Agent Framework seems I just need to work with agents. I would just be able to work with agents. No, that's not true. You can still integrate your applications in very cool way. By the way, agents is a very good way to do most of your things, but we have the Microsoft Extensions AI inside of it, and you can also use just the Microsoft Extensions AI if you need. So in a big picture, from now they will keep the Microsoft Extensions AI forever alive. This is the abstraction we have. Cement Kernel has gone. AutoGen has gone, and we have the math in place. Math now is in the GA, in the RC release candidate. So something can change from what I'm showing you today, and some things like Dev UI is not ready yet. Okay, so there are some features that are just ready on the Python because math supports C# and Python. So they are ready for Python, but not for C#, ironically. But anyway, okay. Math itself, we can use to create agents, create workflows, which is a good topic, create tools, and a lot of things. That's what I'm showing you now. This tools is just an overview. Then we go to the code to see it in action, right? So we have this kind of feature inside Microsoft Agents framework, which they call tools. Is the same thing as we have on MCP, for example, which we can, let me zoom this to you. We can simply bring some code and create here a description. Look at this. This is inside the system component model. That's so cool because they they read the metadata from the class, so you don't need to create anything special on your code. You just need to put a description for it, because sometimes your method itself is not very descriptive, or it's too short for the LLM. And here comes the global point that I'm showing you. As we are working with a agent's LLM, we need to understand how an LLM works, how to feed an LLM to have the right output. So this is the example from the site. I will show you a tool I created. So it have a description here, get weather for a given location. And for the parameter here, location, for example, it also have a description here. So we need to pass this information to LLM, because the agent will try to find a tool, and since it find a tool, it will try to map the text you input to the parameters. So not sure if you get this, but this is the trickiest part, because it can map for a parameter that you don't want. So
Mhm.
okay, if there are any question, you can send it here. Okay, Marcel.
Yeah, yeah. As soon as
Okay,
they come, like it's more specific. Yep.
all
I'm
right.
okay.
This is a tool I'm gonna show you. And for example, we have this inside our agent that is to grab all the CS files inside a repository, a GitHub repo. So return all the CS files in a public GitHub repo, and then from URL we have the GitHub repository URL. Okay, so
Mhm.
please ignore some Portuguese words because I took it from
Yep.
production.
Yeah.
Okay.
We got a question here, right? I think like we're gonna get to this point, but like how so Tim just mentioning about how he can set like a different model, right? I think you're gonna get to that point
Yeah.
still.
Yeah.
But
That's
yeah, I just bring the question because people are just coming with questions.
yeah. Okay. Marcel told me that we have until midnight here, so I prepare for our session.
Stay with us.
Okay. Uh, so tools are this kind of things, and I really appreciate that they made it so simple to us. Okay, I like to create tools separate from my. By the way, I like to create agent products at most of time separated from my main code base. Okay, in a more architecture perspective, because I don't want to allow interaction with uh, any unwanted methods from my code. So most of the time I created it in a separate project and give it access to what I want. So, but it's very easy to do it. It do not require, you can even put this on your services if you are already services mapped, your repositories, if you're using repository pattern, for example. Just be sure that AI will can interact with this. And for example, if your agent, I will talk a little bit about publishing an agent, but if you're using, for example, Copilot Studio, you can publish your agent for the web, but you can also publish your agent inside your team's organization. So everyone that has access to this agent, which has access to this tool, will be able to access this information. So be aware of that. Okay. Another thing. So the tools basically it's just simple as that. Not sure if you had contact with semantic kernel before, but in semantic kernel we had something very very similar to that. To create a tool is very easy. It's just to decorate some methods, and you're done. So by the way, at the during the code generation process here, it will generate the metadata, which will be a JSON, which will be embedded and let the agent know which tools they can call. Okay. Another thing that we have here in math, this is completely new for the semantic kernel, from people which came from semantic kernel, for example, which is multi-turn conversations. So we can create sessions, and here comes the answer to the previous question. We can use different models here, and using the client, the prompt itself is also multimodal, which means we can send images, text, audio to that. Okay, we can send a binary stream here. Okay, yeah, I think somebody. Oh, you did that. You put on the chat,
I
right?
replied. Yeah, I'm
Yeah.
kind of trying to manage the chats, but
All
yeah,
right.
as they come, I'll pop in here.
All right. I'll break down this section here, but the main goal here is that we can create multiple agents. That is the main purpose of the agent framework. So we can have multiple agents, and we can run the same agents multiple times if we need, and we can share the conversation between the agents, because as I previously mentioned, an LLM itself, or the vanilla LLM, it just have the information that was trained, so they do not have any additional information. So the context, for example, is very important here, and we need to keep this context, and we need to keep this conversation. This is I think this is the most challenging part of any AI system, is built around the RAG, retrieval augmented generator, because to better answer a prompt, to better answer a user, you have to have the history. And so the context you had previously with this user, you need to store this in a database, for example, and you have something very special in LLMs, which we call context window. So you cannot simply load all the conversation but in the LLM. Uh, Most of the time, we will need to compact this conversation, compress it, and send just the most important parts to the LLM itself. So here we can create a session using agents dot create session. By the way, let me break down here. In this case, in this situation, I'm using the OpenAI client. Okay, and this is the syntax you will use for any other models. For example, if you're using Ollama local on your machine, you can use the Ollama or Ollama client. You can use Copilot, and then you have this interface here, Get Chat Client. This is basically from Microsoft Agents, Microsoft Extensions AI, and then you have as AI agent. Okay, this will bring the piece of code that we want. This instruction is just the system prompt here. The system prompt is a special kind of prompt that we can send to an LLM before we start conversation, and we can basically give it some instructions, right? So in this case, I said you're a C# and .NET instructor, and here there's our respond in Portuguese, Brazilian Portuguese. We'll change to English to check later. Okay, then we can create a session and share this session with the agents. To run an agent is very simple. Agent.run async. Okay, and to create a session is also very simple. Create session async. Just keep in mind that this session I created here for this example, this purpose, is an in-memory session. Okay, This is not being stored in any place. You can create a custom store provider to store it if you want. And in my personal opinion, if you creating a very serious project, you need to store the sessions, and you need to have a very good observability around agents, because you need to understand which input agent grabbed, which output agent did. So we need to do some kind of reinforcement learning here. Okay. Uh, there's a good question here. Do you want to bring it
Yeah,
from Tim?
I was just showing before, but you mentioned about like the models, right? So
Yeah,
it only work with models available on Azure?
no,
That's
no. That's also the other good point that I like here, because for example, I really appreciate Azure AI Foundry. I see you guys told them something about that previously on the chat. I think that Microsoft got the right perspective from AI. You just came with AI, plug it into the customer network, and that's it. But for my case, which is a very small business, for example, I most of the time use Copilot, so I can have multiple models inside that. But here, the only syntax that it will change, you will create an Azure Open AI client. This is the only
Mhm.
syntax that will change. So you're using the Azure, which I truly encourage you to try if you're doing a very serious AI product. Okay, so this is the feature. We go then to memory and persistence, which is the key point here. So for this scenario, for example, whoops, let me just zoom. Okay,
Yeah.
we have a custom chat history provider. So this is the guy I told you before. So we are doing the instructions to the chat options here. The code is basically the same. I just created a chat options uh, object here. Okay, and I can pass a chat history provider. Again, to do this is very easy. You just provide a custom chat history provider. But behind the scenes, there's a lot of work to do. This is a very tricky part, because, as I mentioned before, you have to store all this data. You have to compact the data. Sometimes you have to work with chunks of data, because you don't want to feed an LLM with all those tokens at the same time. So it's a little bit tricky. I really recommend you to spend some time here. Okay. I will not cover this part here because we do not have so much time. Then we move to workflows, which is the last piece here before I promise I'll go check some code. And the workflows itself, it's just the ability that we have to chain multiple agents together. So we can create a workflow. It's a good name for that. And so we can create some classes methods, and we can chain them together, passing them to our workflow. So we have different kinds to execute this workflow. They can execute parallel, they can execute async concurrently. Uh, there's a lot of information about that. But the good part is we can simply inherit from executor class and add a handler annotation here. For example, this is the same, this is part of the previous code, which I brought here. And this is just the part that do the code review feedback. So this is a class that I have to do some code review. So if I want to do a code review, write an analysis report about this code review I just did, send an email to the customer, waiting for the customer to approve, because we can have human in the loop. We can wait for this approval. Then we can tie everything together in this workflows. Okay, here. We also can do this. We can simply have a method and uh, create a notation saying, hey, the executor ID is the analysis report. So this is the analysis report. You don't need exactly to have a class to handle this. And so we can tie this together later, okay? Whoops, sorry about this table. Last piece here is hosting. We can expose these agents we created. As you may imagine, through web, we can create a web application that runs this agent. We can simply run this on a web. We can expose this using HOA. HOA is like MCP, is a model context protocol for LLMs to exchange tools and other capabilities. HOA is a protocol that we have to communicate between agents, and we can expose this through Azure Functions, which is a very good approach also. Most of the time it needs to be the durable functions, which have a large amount of time. Okay, and then we have the AGUI protocol also. This is a relatively newer protocol, and we can also access this from front end. It have a GUI. It's very good, very nice. Okay, but let me show you some code here. Let me bring my JetBrains Riders, sponsored by JetBrains. All right, let me do a quick zoom here.
Yeah.
Okay. All right. As I mentioned before, this was extracted from my production environment, so I had to modify something, some piece of code here to not expose some things that we have here. And we also had to, I also had to cut it into some pieces, because everything together will be a little bit mess. And this code is, you know, I made this in a few hours, so this is not a clean code. This is not anything like that. So I go to parts to understand the code, and to catch where to use agents, where to run the agents, and where to use your C# static code. Okay, this is the main catch here. Create agents is very easy. And I also mentioned before, but as GitHub has limitation, rate limit, I think is 2,000 requests per hour, 2 or 5,000 requests per hour. But as we cannot increase this amount, even paying. As we have so many students, we could not do this on the fly. So I create a console agent which runs on my desktop here above my desk, and this is the AI that powers this agent when we do some sort of challenge here. Okay, so first things first, let's take a look at the program, because this is very cool. So here I work with Microsoft Extensions configuration to bring the Open API key from my .NET user secrets. Okay, so this is the basic configuration here. And we have here the configuration for the agent. This is the review agent. And the code is the same that I present to you. I will switch here to always respond in English. Okay, right? Then I can switch back to Portuguese just to see that. I also fixed a GitHub repo here, which I have and it's open source. Okay, just to recheck that. So we have a review agent, and review agent itself is just an AI agent with some restrictions here. Nothing special about that. We can we can replicate the same thing here just using Microsoft Extensions AI, which is uh, not showing here because it's already inside the Microsoft agent framework. Okay, and we can simply replicate this using Microsoft Extensions AI just by giving a simple prompt. Okay, so just a system prompt and the prompt itself. But the good thing here is this piece of code is reusable, so I can reuse this agent. I can put this inside a class using dependency injection here and use it wherever do I want. Then we have the workflow itself. I created a code review workflow, and then we can run the workflow here, passing the agent or the agents that compose this workflow. And again, since we have just one, just in memory session, it is automatically, it will share the session with the agents, all right? So this workflow is a little bit specific, so it will run, and the workflow itself. Here I just using ANSI console because I'm using console.spectre to create a better prompt here. And here's the report that is generated here. And we have the summary, the grade, the overall scores, encouragement, strengths. This is all about this GitHub repo here. Okay, right? So this is the main goal here. So where is the code itself? To code this, we took some different approaches here. The first one, I do not want the report itself just to be a simple text, because I want the report itself to be typed, to be strongly typed, because I want the same report to all students. I don't want, for example, as I mentioned before, AI is stochastic, so it can generate a summary for this first case, but cannot generate summary for the next case. So it's most unpredictable. So what we did here, we created a model called GitHub code review feedback. So the output, I can say the agent, I can force the agent to output for me this type. So this is one thing that I really appreciate here, and really appreciate to do when dealing with agents, is not to return a simple string, hey, generate a report for me. No, generate a report using this this information, and he is smart enough to understand that. So when we try to this under the hoods, he will serialize it. It will serialize it, understand these properties, and as he does it, it is smart enough to understand that, wow, I have to create an overall score. I have to create a grade. I have to summarize this report. So the properties itself become the instructions you give to the agents, right? So that's why we have this type here. Okay, my run async will always will return a code review feedback instead of simply return a string. This is the main point here also. And another thing is that AI can review our code. We can simply pass a .cs file to AI and say, hey, review the C# code for me. But we have such a power inside C# with Roslyn, for example. We can do statistical analysis from our code that I think it's weird to delegate this to AI and hope it can do a better review than Roslyn itself.
Mhm.
So we have a static analyze report, and we have errors, warnings, and infos here, right? So these are three simple lists here. And we have here two tools that will support our agents. The first tool I already show you because it's the GitHub repository tool. This tools allows the agent to go to the GitHub repo, download the CS files here, right, and interact through all this CS file. I won't go through the code here because this is just the C# code to do that. Okay, there's nothing related to math inside this code unless this descriptions here. So we have the description here and description here for the parameter and for the method itself. And as you can see, it comes from the system component model. There's not related to math yet here. So you can put this in every service that you want. So this method returns a GitHub repository content, right? Which is the owner, has the owner, the repository itself, and a list of GitHub file content. This is the C# content that we have. So with this in mind, we just need to interact through all this C# code and do the code review itself. Here comes the catch. I tried it the first time to just send this C# to the LLM and said, hey, do a code analysis for this C# class, for example. It worked well. It worked good, but it produces some different results for each class, which will not be fair for our students, because since we have a way to classify all the repositories, we have to apply the same rules to every student. This was the first time. The second part was the token consumption, because as we feed 23,000 repositories to the LLM itself, it consumes a lot of token. So we decided to do this using Roslyn here. So we have a statistical analysis tool, and then I removed a lot of code here because we have a lot of code, and this is still in Portuguese, sorry, but which means do on a statistical line of C# files and returned by the fetch repository. Okay, this is just the description. So this is the C# code. So we are balancing here the content that we want to be generated by LLM, for example, texts, summaries, which is also good. But we're balancing this code with statistical analysis with C# code, for example, to not spend so many tokens and to do things that we do not want to be stochastic. We don't want to produce different results every time. We want to produce the same results. If the class has more than 2,000 lines, so we have a warning here. We want to say this. I'm saying I'm talking about Roslyn and analyzers here. This is not compile. Do not compile the code. This is just do an analysis, right? Okay. And so this is the tool. This is not marked as tool or nothing. This is just use also the system component model data annotations here, right? So we have these two tools here, and then we have our workflow here. Okay. The first thing it does is fetch the repository, then it analyzes the repository with the statistical tools, right? Then it generates the report. So we just use the agents here in this step, the third step, right? We can do everything here on the screen. We can do using the agents. We can add an agent, for example, to do the GitHub fetch. We can create an agent for that. Say, hey, since the repository is public, we can create an agent saying, hey, walk through this repo, grab all the CS files, and bring the content to me. But it will spend a lot of token. It will need to create a Python script for that under the hoods to do that. So we can do this in C#. It's very easy to do. We had the OctoKit SDK. So not sure if you got, but it's not that why it's not because we are using agents that we need to use agents for everything we do.
Yeah.
We still can create a lot of code. Same for analysis, as I mentioned before here. So here comes the agent part itself. So we have a build review prompt here, which is a function that returns a string. It says generate a technical detail report using this data, and I serialize the repo and the static repo. And here we have the agent. We pass the agent here. This is the abstraction itself. So every time you need to pass an agent to a function, you can do that. That is very cool because every agent here in Microsoft Agent Framework is a chat client agent. So is a chat client, or it can be any other model types. But a chat client is the most common one. So we can pass the agent here and execute the agent in our code. And this agent itself, when I use run async, since I want the result to be standardized, I pass the object here. So it will use the LLM. It will use reflection here because we do not have any kind of metadata for this object. It will pick the properties from this CS class here, this object, and we'll fill this property. So he work in this condition. Obviously, it will produce different data if I run multiple times because, as I mentioned before, but it will follow the class here, the code review feedback, which has the summary, the grade, the overall content, and everything else, right? So the result will be this object. So we passed this before, and so in the program here we have the summary, right? Let me run this. Just this you'll have better view. It will take some seconds because it's a lot of work to do with LLM itself. Okay, and here as I use the run async here, which will run, grab everything and output to the screen. But we can use the stream as async also to do a streaming from this. So this is the result, the summary, the code activates a good structure. The grade is B, is from A to D. The grade is B. The overall score is 75. Okay. It has some encouragement message here, which we use to send to the student, say, hey, you're on the right track. The code has solid foundation. Strengths, no, it utilizes any framework, the improvements, the code example, and here also some next steps which can the user can do to increase the code. So this is one agent inside a simple workflow, but it's a real world agent. Uh, at the end of this agent in real production, it generates a markdown with these instructions here. So with this markdown, we can send it to another agent, right? And then we can start to write an email, writing a lot of code. Since we do not have enough storage to store this agent, start the conversation, we use the MD, the markdowns to
Hmm.
as a storage here, right? Okay, so that's it. This is the demo here.
It's interesting that so you balanced, right? Like for like where you don't need to leverage an agent, you took like Roslyn and implement like this um, well, the validator, right? Like without LLM. And then where you need it, you knew like you want like to leverage tokens, and then you were very specific, right, about like creating like the score and put like the properties in there, even like converting that onto an object, right? Because in general you get like this sort of output, random outputs, but you're just typing the results in there. That's pretty cool.
You know, something that I noticed when we did it last year, just updated to the newer version of math this week, since we have this talk here. And something that I noticed is that we focus so much on the tool, on the framework itself, but we forgot the main piece to be discussed, which is when to use an agent, when to create an agent, when to balance it with your code, when to reduce costs, because AI itself is not a cheaper thing. If you put it on a large scale, uh, it will be chaotic. So we need to balance everything like that. So this is why I try to bring you here this different vision, not just regarding creating agents using math, because I don't think this is a very tough task. They have a good documentation, and
Yeah.
Cloud can work for us like that. But
Yeah.
I think you have this feeling, and this is driven by your business. It's
Hmm.
hard to have. There's no golden rule. Say write an agent, and that's this situation or that situation. It's fine grained to your business, but it's very important for us to have this vision, because you don't need to write an agent for everything.
Yeah. It's a good point, right? Because a job, let's say an agent without a brain, it's just a job.
Yeah, yeah.
Right? So there, that's like you're just balancing like the costs. Like, do I really need like bring like LLM onto like what I'm doing here? Probably, maybe, right? If you do it, then you take like LLM, become an agent, bring those tools, and leverage that, right? I really like the way how you put it in there. We have like some questions in here. I think
For
Andre,
sure.
let's
Sure.
see. Like, is there a way to see how the agents orchestrate flows in the background?
Yeah, we have two important things here. The first one, you can use .NET Aspire to run your agents locally, right? This is the main step here. We did not implement that because, as I mentioned before, this code is being portable to the newer version, and we're still in release candidate on the math. But it already has support for .NET Aspire, so you can use the Aspire dashboard to make some initial tests to your agents. But the agent itself, needs to be plugged in any kind of observability tool you have. Okay, because you need to really understand what is going on behind the agent's execution. So if you're using Prometheus, any kind of tool that provides you this kind of observability, it is very very important. And regarding the orchestration or the flows, we have different kinds of workflows. We have this kind of workflows that is synchronous, which I show you. It will execute in this order, uh, has this short leave and then die. But we have uh, kinds of workflow that works. I'm not saying background, okay, but because they need to leave, but they can stop, they can pause, they can wait for you to take an action. For
Yeah.
example, I can plug it into my email, and since I got the approve from my manager, the workflow will continue. We can have
Stateful,
something like that, stateful
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 workflows. Yeah.
workflows. But you need it, as you may imagine, it need storage, so we need to be persistent, right? uh, and you can trigger the agents in very different formats. You can use Chrome based uh, triggers to trigger time. You can have the HTTP trigger to trigger this agent. You can have, like we had before, the C# code that triggers this agent, right?
Hmm. Yeah. Well, I don't think like we have like other questions in here.
Great.
But like it feels that's yeah, that was like a really uh an intro like to Microsoft Agent Framework with workflows. It's things are well, there are lots of features in there, right? So like what you brought in here, Andre, was like yeah, this sort of the foundational aspects of math. And people they're interested like just take it and start like creating your different flows. You brought like a use case in here, like with the review workflow, and then like, well, that's nice. You can make even things more complex, right? Depending on the
Yeah,
business flows that you have. Yeah, that's pretty good. Yeah, I'd like to thank you just for for being
sure.
available like such early morning for you.
That's good.
Yeah, it's oh, it's our pleasure just to have you here. And well, you're welcome to come back like anytime, Andrea. Like yeah, just yeah, I'd like to thank you. And I know like this video is going to be like on YouTube and others are going to come in here and watch like your contents. And yeah. Uh
Great.
well, if you have like your link, like or if you want me to share in here like on the comments, people can just click and go through
uh, I
your
think
website.
I will send you my LinkedIn,
Yeah,
as I think is the right place to find my content in English,
yeah.
because I produce a lot of content in Portuguese, so
All right.
uh,
Yeah.
sometimes it's hard to translate.
Oh yeah, yeah.
But this is my LinkedIn, and if you're trying to if you're willing to do something with my Microsoft agents, I truly encourage you to test, to put in practice, to create agents, to see what needs to be agent, what can be stat code, how you can connect this to your ecosystem, because it's not difficult to do an agent, as I mentioned before, but I think the real advantage to use agents is to balance between your code and uh, agents doing your tasks.
Cool. Again, thanks so much, Andrea. Thanks for the audience. Stay with
Thank
us
you.
like until now. And we should have other sessions coming like on the user group. So just jump like from the meetup you came through, and then you can check like the next session that we have booked up. And well, thank you like for staying with us. Thank you again, Andrea. Yeah, and see you guys next time.